Between December 8th and December 11th, 2007, a meteorological pattern established freezing rain conditions across Oklahoma and portions of adjacent states. Ice accumulated on exposed surfaces for more than 60 consecutive hours in some locations. Power transmission infrastructure, distribution networks, and vegetation-coupled systems degraded progressively under sustained radial ice load, producing widespread service interruption without catastrophic wind or structural event. Oklahoma's electrical infrastructure in December 2007 operated within a region characterized by minimal winter ice preparation compared to northern tier utilities. The state's grid architecture featured overhead transmission and distribution lines routed through suburban corridors with mature tree canopies. Vegetation management protocols varied by utility jurisdiction, with trimming cycles often extending beyond optimal intervals due to cost constraints and right-of-way access limitations. Typical winter conditions included brief freezing rain events lasting 6 to 12 hours, with ice thickness rarely exceeding 0.25 inches on exposed conductors. Design standards for pole loading, conductor tension, and guy wire placement reflected these historical norms. The December 2007 event would exceed both duration and thickness parameters by multiples sufficient to compromise system integrity across urban Oklahoma City, Tulsa, and intermediate communities including Edmond, Norman, Stillwater, and Broken Arrow. The storm's atmospheric structure developed from a classic warm air over cold configuration. A shallow layer of sub-freezing air, anchored by northerly surface flow from a continental high-pressure system, remained trapped beneath an advancing warm front aloft. Precipitation falling from the warm layer entered the cold layer as liquid droplets, reaching ground-level surfaces still below 32 degrees Fahrenheit. This produced freezing rain rather than sleet or snow. The layering persisted due to slow frontal progression and sustained moisture supply from Gulf origin systems tracking northeastward. Soundings from Norman, Oklahoma documented inversion profiles supporting supercooled droplet persistence for extended periods, creating conditions favorable for accretion continuation without interruption. Surface temperatures remained between 28 and 31 degrees Fahrenheit across central Oklahoma for more than 50 hours. Upper-level temperatures at 850 millibars remained above freezing throughout the event, maintaining liquid precipitation supply. Freezing rain began across western Oklahoma during the evening of December 8, 2007. Initial ice accumulation rates ranged from 0.05 to 0.10 inches per hour on elevated and exposed surfaces. Utility crews documented glaze ice forming concentrically on power lines, transformers, and guy wires. Tree branches in urban areas accumulated similar radial ice shells. By the morning of December 9th, ice thickness measurements in Oklahoma City metropolitan areas reached 0.5 inches on horizontal surfaces and conductors. The precipitation continued without cessation through the day. Atmospheric conditions remained stable, with no temperature rise or precipitation-type transition observed in surface reports or forecast model outputs. Utilities activated emergency operations protocols, pre-positioned crews at strategic staging areas, and initiated mutual aid requests to neighboring states. However, restoration capacity remained contingent on cessation of accretion, which had not yet occurred. Forecasts indicated continuation through at least December 10. Ice accumulation continued through December 9 and into December 10 without atmospheric relief. Observations from cooperative weather stations recorded cumulative ice thickness exceeding 1 inch in central Oklahoma zones by the afternoon of December 10. Radial ice loads on cylindrical conductors increased proportionally to thickness and density, which averaged 57 pounds per cubic foot for glaze ice. The weight of ice per linear foot of conductor exceeded design tolerances established for Oklahoma's climate zone, which typically assumed maximum loading of 0.5 inches with concurrent wind. Tree limbs, weighted beyond mechanical failure thresholds, began separating from trunks. Falling limbs contacted energized distribution lines. Initial outages appeared in clusters corresponding to tree-dense neighborhoods in older suburban developments. Utility dispatch logs indicated failure rates accelerating as accretion duration extended beyond 48 hours from onset. Crews reporting from field locations noted ongoing ice deposition preventing immediate repair attempts on cleared faults. Tree failure became the dominant mechanism for distribution-level outages across metropolitan areas. Oklahoma's urban canopy, consisting largely of Bradford pear, elm, and oak species with broad lateral branch structures, proved vulnerable to radial ice loading beyond approximately 0.75 inches. Branches failed at attachment points, dropping onto 12.5 kilovolt and 7.2 kilovolt distribution lines. In areas where trees overhung or grew adjacent to power corridors, failure rates approached 100% of circuits within those corridors. Utilities documented thousands of individual points of tree-conductor contact across service territories. Falling limbs also severed guy wires supporting distribution poles, inducing secondary structural failures when poles lost lateral support under ice load and conductor tension. By December 10, restoration crews were unable to proceed with repairs while ice continued accumulating and trees continued shedding load onto circuits cleared only hours earlier. Field supervisors reported repeat failures on identical circuit segments, necessitating suspension of energization attempts. Transmission-level failures occurred where ice load exceeded conductor and support structure ratings. Oklahoma Gas and Electric and Public Service Company of Oklahoma reported failures on 69 kilovolt and 138 kilovolt lines due to combined ice and dead load stress. In some instances, entire spans dropped when support structures, wooden poles or lattice towers, failed under lateral or vertical load components exceeding foundation or structural capacity. Conductor galloping, induced by asymmetric ice shedding and wind interaction at velocities as low as 15 miles per hour, contributed to phase-to-phase faults and automatic sectionalizing by protective relays. Substation equipment experienced insulator flashovers due to ice bridging across air gaps designed for dry conditions. Automatic reclosers, attempting to restore service after transient faults, cycled repeatedly before lockout, complicating fault location efforts. By December 11th, portions of the transmission grid were offline, compounding distribution system isolation and eliminating sectional restoration pathways that would normally allow rerouting of load. Power outages in Oklahoma City exceeded 200,000 customers by the evening of December 10th. Tulsa reported similar figures. Suburban municipalities, including Edmond, Norman, and Broken Arrow, experienced near-total service loss, with some areas reaching 95% of customers offline. Restoration timelines extended into days rather than hours due to the scale of simultaneous failures and the necessity of waiting for ice melt and tree stabilization before safe re-energization could occur. Hospitals operated on emergency generators, with fuel resupply becoming a critical constraint as road conditions deteriorated. Residential heating systems, predominantly electric resistance or natural gas fired with electric ignition and control systems, became inoperable. Ambient indoor temperatures in unheated structures declined toward external conditions, which remained at or below freezing through December 12th. Duration without power in some areas exceeded 7 days, with full restoration requiring 2 weeks in hardest-hit zones where infrastructure required complete rebuild rather than repair. Transportation infrastructure degraded under ice accumulation on roadways, overpasses, and traffic control systems. Ice thickness on roadways reached 0.5 to 1 inches, prohibiting vehicle traction even with tire chains or studded tires. Interstate highways, including I-35 and I-40, experienced closures or severe restrictions, with Oklahoma Highway Patrol reporting multi-vehicle incidents at multiple locations. Fuel distribution networks encountered operational interruptions. Gas stations without generator backup could not pump fuel due to loss of electrical power for pumps and point-of-sale systems, and electronic payment networks were offline. Road crews faced equipment limitations. Ice removal required mechanical scarification rather than chemical treatment, and prolonged freezing conditions prevented effective melting, even with application of calcium chloride or magnesium chloride brines. Commercial deliveries halted across the region. Emergency vehicle response times increased substantially, with some jurisdictions reporting delays exceeding 1 hour for priority calls. The transportation shutdown compounded power restoration delays by restricting crew mobility, equipment staging, and material delivery from out-of-state mutual aid resources. Municipal water systems experienced pressure loss and localized supply failures as electrically driven pumps at lift stations and treatment facilities went offline. Boil orders were issued in jurisdictions where backup power was insufficient to maintain chlorination or pressure. Some systems experienced pipe freezing in above-ground installations exposed to prolonged sub-freezing temperatures without circulation. Communication networks degraded as central office battery reserves depleted after 24 to 48 hours, and fuel resupply for backup generators encountered transportation barriers. Cellular towers operated intermittently, with coverage gaps expanding as tower-mounted battery systems exhausted. Natural gas distribution continued in most areas as pipeline pressure regulation required minimal electrical input, but service calls for pilot reignition and system troubleshooting overwhelmed available technician capacity. Shelters opened in facilities with backup generation, including schools, community centers, and churches, but access remained limited by road conditions. Medical facilities reported increased admissions related to carbon monoxide poisoning from improper generator use in enclosed spaces and hypothermia from prolonged cold exposure indoors. Official assessments documented over 600,000 customer outages across Oklahoma at the storm's peak on December 10th, representing more than half of the state's electrical customers. The National Weather Service confirmed ice accumulations exceeding 1.5 inches in portions of central Oklahoma, with localized reports reaching 2 inches in Cleveland and Oklahoma counties. Restoration costs for utilities exceeded $100 million, not including economic losses from business interruption and infrastructure damage outside the electrical sector. The Federal Emergency Management Agency issued disaster declarations for 56 Oklahoma counties, authorizing individual and public assistance programs. Post-event reviews by utilities and state agencies identified vegetation management frequency, grid hardening through increased pole class ratings and conductor specifications, and mutual aid coordination protocols as primary areas for protocol revision. The 2007 Oklahoma ice storm entered records as one of the most severe ice-related infrastructure events in the south-central United States, defined not by peak intensity metrics but by accretion duration and cumulative system load applied over time.